The chain rule is plus or times.
So this isn't actually chain rule. What rule is this going to be?
Product.
This is the product rule. Yep. I guess if you wanted to get really technical, you could say it's like product rule and power rule. But this is one function multiplied by another function. Looks like Luke's kicking back. What is the product rule? Do you remember, RJ?
I remember wait, x plus f of x plus a plus minus f of x over.
That's the quotient rule.
Quotient.
Luke, do you remember the product rule, Luke?
Yeah, it's just the derivative of the first times normal second plus second times normal first.
Exactly. Yeah. Okay. If I happen to do this backwards, Luke, is that okay?
Yep.
Because I always do derivative of the first times the second, plus the second times derivative of the first. But you do. Sorry, which way do you do it, Luke?
I change it every time. I just pick one. I did it the first this time.
So, hey, you want to tell us what you got then?
2x times e to the power of x plus x squared plus 1 times the power of x.
Yeah, that's right. So you did derivative of the first times the second plus first times the derivative of the second. And RJ, this is that old thing. Where do we go from here? So we need to find out where the tangents are horizontal. So we know the slope is 0. And what should we do on the right-hand side when we're finding maximums and minimums all the time?
Factor.
We need to factor this. Yep. So what's a common factor in there, RJ?
Yeah.
E to the exponent x. Yep. So it's a little bit of faith here that this is actually going to work out into something beautiful. Interestingly enough, if you were doing this in real life, like most of them would turn out to be pretty ugly. I'm just going to rearrange that to make it more obvious. What's that funny sound?
That's Reed talking, I think.
Is he still out there?
I don't know.
So that's what I thought. I was giving him credit for beeping a lot. Okay.
X plus 1.
Good. Okay. So there it is. It's all factored. So, pardon me, yeah. E to the x is never equal to 0, right? Any value of x, the domain, anywhere in the domain of that function, the function's never equal to x. But x plus 1, well, that's equal to 0 and x is equal to -1. So if we wanted to finish it off nicely, we'd say tangents are horizontal at -1, and that'd be 2 over the Euler number. Did I get that right?
No, it's 2 times. Yeah, 2 times e to the power.
Yeah. All right. Good. So that's derivative of exponential functions. That's derivatives of the exponential functions. Sort of with our crazy rules. Okay. Oops, wardrobe malfunction. So here's our function. X plus 1 plus the natural log of x plus 1. So does everybody remember what the derivative of the natural log of x is?
E to the power of x.
No?
Or what?
No?
Oh, okay.
Yeah. It's 1 over x. So when we're doing derivatives, we wind up doing a 1 over x thing. Okay. So find the slope of the tangent. At 0 and 1. So when x is 0, 0 plus 1 is 1, and the natural log of 1 is 0. So find the slope of the tangent at 0 and 1.
You can't remove this one.
Yeah, so there's a sum rule, obviously, right? And then there's a chain rule when we're doing that, but
Yeah.
it actually doesn't make much difference. All right, what'd you get for the derivative, RJ?
No, I'm not sure.
Haven't got to it yet? Luke, what do you get for the derivative there?
1 plus 1 over plus 1.
Yeah, that's right. So it is like a chain rule question, but the derivative of x plus 1 is just 1. So it's no big deal. And to find the slope, all we have to do is plug in 0 for x. That's easy. So we wind up with a lot of, like, the natural log actually ends up being kind of convenient when you're doing calculus of functions of, like, inverse relationships. Like potential energy of a particle in space. Okay. So let's we're going to do another natural log question. It's just one of those variations again. So here's our function. This one is a chain rule question. So there's our function, and guess what kind of question? Guess what this one is?
Chain.
It's chain, but guess what it's going to ask you to do?
Find the natural log.
Oh, well, what do you think, Luke?
Find the equation. Find
Find
slope.
slope.
Find the equation of the tangent, find the slope, find where the tangent is horizontal. So that's pretty close. Can you give me the derivative, RJ?
1 over x cubed minus 3x plus 1.
Yeah.
Plus 3x squared plus 3.
Okay, so it's going to be times
Or times
3x squared
plus 3. Or minus 3.
minus 3. Yep. So I'm going to put that up on top. 3x squared minus 3. And who's our best friend when we're doing these ones? Luke knows.
The bottom, you can just times it. Top, there,
Yeah.
the top, denominator.
So whenever we're in this kind of situation, we need to find the zeros. What should we do?
So the top equals 0.
Yeah, it's where the top equals 0, so we're going to factor the top. So I guess we're going to ignore the bottom. It's just where the top is equal to 0, so we're going to find out where x squared minus 1 is equal to 0. This one does factor. Do you know the factors for this one, Luke?
1, negative.
Yeah.
The zeros are 1 and negative 1. That's right. Yep, that's right. And if I set those in to the bottom, I can see it doesn't send my bottom to 0. So tangents would be horizontal when x is equal to 1. and x is equal to -1. So that would be the natural log of that would be -1, and that would be +3, 6. And I know the natural log of 1 is 0. Okay, so we've done logs of exponential functions that are base e. We've done derivatives of exponential functions that are base e. We've done derivatives of logarithmic functions, natural log functions. And so, really simple. What is the derivative of y equals 7 to the exponent x? So these questions actually are just like doing the derivatives of exponential functions. They just have one additional wrinkle to them. So the derivative is basically, it's just the exponential function, but because it's not to the base e, we've got to factor. We've got an additional, sorry, I don't mean verbally or physically factor it, but we've got another thing multiplied in. Luke, do you remember what it was?
Is it like I or sort 1 or something? Or?
It's actually the natural log of whatever the base was.
Well,
so it's the natural log of 7 times 7 to the exponent x. So the derivative of like an exponential function to a different base, just like the derivative of exponential functions base e, except we just have to multiply by the natural log of the base. Okay? Other than that, it's the same game. Basically the exact same game. Okay, maybe I'll skip that one for now. Okay, so now I've got a logarithmic function, but in this case the log function is base 5. Now there's a change of base formula, but you don't really have to, go through the song and dance of doing the change of base formula every time if you don't want to. But this has an equivalent form. Oh, this is a bad choice. So I can convert this into a natural log function. The only thing that's a little bit different is I have to divide by the natural log of the base. Okay? So unfortunately, we've got a couple of 5s in here that make it a little hard to understand. But because that's log base 5, we're dividing by the natural log of 5. Okay? Other than that, basically it's the same thing. Natural log of 5 is just a constant. It's a number. So it's just like if that was a 2 or whatever. Okay. Let's do the derivative. Okay.
Oh, yeah.
Did you get it, RJ?
Yeah.
Luke's done all the other ones to now.
Well, I know what's wrong.
Okay. Okay, 1 over the natural log of 5, that's just like a number. You can use the constant rule. What's the derivative of the natural log of 5?
1 over 7.
1 over 5x, yes. And then you have to use the chain rule. So I have to do the derivative of the inside function as well.
5.
Times 5, yep.
Okay, let's keep going.
So those cancel. So there's my derivative. So just to reiterate, that's not much different than taking the derivative of a natural log function. It's just that you get this extra coefficient in there. Okay. Last one. Okay. Luke, is it okay if RJ takes a shot at this? He wants to get one.
Yep, yeah.
Negative sin x.
Negative sine x. I don't think so.
Yeah, because I was thinking the 1 over the x comes down, which makes that exponent 0, which makes that 1. 1 times n.
Okay. So it's product of two functions, so yeah. So derivative of the first times the second, there I'm going to do it that way, plus the derivative of the second, which is sine x, and that's going to be times the first, which is x.
Why is it a minus instead of a plus?
Oh,
Yeah, that's the negative sign.
what's that?
Isn't it sine, cos, negative cos?
Derivative of sine is cosine. Derivative of cosine is
Negative sign.
negative sine.
Alright, so that's negative.
Does that make sense, Luke?
Yep.
Okay. Right. Okay. Let's do this. I said that was the last one. Turns out I lied. So here's our function. And guess what we have to do this time? So there's different genres, right? There's find the equation of the tangent. We haven't done one today. There's find the slope of the tangent, and then there's
Where it's horizontal.
find where it's horizontal. Yeah. So because these are periodic or tend to be periodic, we're going to say on the interval 0 to 2 pi, inclusive. Oh, I didn't call it f of x. Find where the tangents are horizontal.
No, like, Curly. Alright, great. So do the warm up. Alright.
Okay. What do you get for a derivative, Luke?
1 plus 2 sin x.
Perfect. Now what do we do?
Set the derivative equals 0.
Set the derivative equal to 0? Yeah, that's right. So we're interested in places where sine x is equal to negative 1/2. So we're going to take the inverse sine of negative 1/2. There should be, because we're between 0 and 2 pi, we are going to get 2 answers. So I don't know if you use the circle or not. Ooh, oh, that's ugly. Luke, if you see that, that's a perfect circle here, but the screen's distorting it a bit. What's that?
The right side is
It's not that bad, eh?
No, it's just the right side.
Okay, what are my 2 angles?
Negative 30.
Negative 30, but I have to be between 0 and 2 pi, so. You're right, negative 30. You just need to fix it up.
So 330.
So yeah, 330 if I don't mind doing that in degrees.
Which is equal to
Negative Other ones negative pi over 6.
I don't remember how to say them in pies.
Yeah, so it's negative pi over 6.
Oh, right. So
And
it's,
there's 2 pi all the way around, so
so it's like 7 pi over 6 and like
yeah.
11 pi over 6 something.
So yeah, 7 pi over 6. And the other one would be 11 pi over 6. So yeah, we said it was x. 2 possible values of x there. That would make it horizontal. Sound all right? Okay.
Yeah, well, on the questions in the test,
What's that, Luke?
is there gonna be like one of these type of questions in the test? Like,
Yeah. Yeah, there. Yeah.
Alright.
It would take up like 100% of all your-
Is that all right, or does that?
Yeah, no, that's very.
Yeah, like the big deal is sort of getting your head around, you know, if you get to this place where you're finding the inverse cos or inverse sine of negative 1/2, that's really pretty good. Okay. Remember how I said that was the last one?
It is?
Well, almost, yeah. Remember the one where we did the differential equation? Luke, do you remember that?
Yeah, mostly.
It's like where we took the second derivative. We said the second derivative plus 2 times the first derivative. Anyway, there's going to be one of those, but I'm going to make it fairly straightforward. You just have to find the second derivative of the function and put it into the differential equation and solve it. So I think you guys can do it. It should be fine. Last thing is, if I asked you to find the derivative of secant x, so secant is a reciprocal trig function. What is the RJ's voting for 1/tan. Luke, what do you think secant x is?
1/cos, but that's like not that sure something goes on.
Yeah, it's 1/cosine.
There's one that's something.
Oh.
1/tan is
Cosine.
cotangent.
That's
Yeah. Okay. When we're doing the derivative of this, it's probably better to do it as a power rule question. We'll set it up like that. When I take the derivative,
so negative actually it's not negative.
yeah, so -1 times cosine of x to the exponent -2. I'm not done. What do I need to do now?
Inside.
Have to do the inside, yeah. And the derivative of cosine
Negative sign.
is negative sine x. Okay, so it's starting to look a little bit, needs to be cleaned up. Let's clean this town up. Negative times a negative is a positive, so this is going to be sine of x
Over
the cosine of x
square.
times 1/cosine of x. Yeah, you're right. It's sine over cosine x squared. But we can actually write it as tan of x times the secant of x. Or sec tan. All right. That's that.
That pretty much covered.
That pretty much covers it, yeah. Like we just did derivatives of exponential functions, derivative of logarithmic functions, both base e and other bases, derivative of trig functions, and then derivative of reciprocal trig functions. And like I say, there will be one of those. I'll give you a differential equation, and you have to solve it. So that'll be it.
When you say like differential equation, like what is that?
Okay, so let me see. Okay, let me see if I can find you the example. We did an example in class, and it had to do with the derivative of the law of. It was probably like an Euler number one, so I'll see if I can bring it up here. Okay, so the example we did is there on the screen now. So question number 10, that's a differential equation. So the d squared y over dx squared, what does that mean? Do you know, RJ? That's the second derivative of the function, yeah. And 2 times dy over dx, that's 2 times the first derivative, minus 3y equals 0. Okay? So that's called the differential equation. The actual function we're talking about is listed down here. Y equals a times e to the exponent kx.
Oh yeah, okay, I remember doing that. And I came late to that lesson or something.
Yeah, so that's good if you remember it. The one I'm giving you is actually easier than this one. But basically what you're going to do is you're going to find the second derivative of the function, and you'll put it in over here, right? Then you'll find the first derivative of the function. Well, you probably found the first derivative beyond the second derivative. So, sorry, you do that in the other order. Find the first derivative, find the second derivative. Pop the second derivative into this position, put the first derivative into that position. Substitute the actual function for y. And then when you're all done, you're going to be able to factor it, and you're going to be able to solve for k and a. Now, the one I'm going to give you is a little bit easier than that, but all you have to do is basically hang tight, take the derivatives, and then substitute.
How do you solve if there's 2 unknowns?
If there's 2 unknowns, actually you factor it, and you'll find that one of them could be 0, and then the other one, it'll turn out, it'll break down into factors, and you'll be able to figure it out. Okay? So that'll be like question 6. Okay. Does that sound okay, Luke?
Yeah, that's good.
Okay, perfect. So we'll see you tomorrow. We'll try and start early, so we'll try and get as close to 2 o'clock as we can, and hopefully finish early. Like I say, question 1, set derivative of sine x. You're able to use those 2 limits. You don't have to have as many lines as they have in that proof in the CEMC site, but have the basic idea and make sure the proof flows. Okay, it's good. We'll see you tomorrow then, Luke.
Right on, sounds good. See ya.
Bye now.